Let's take a look at section 2.2, conditional statements. In this section, we get two additional connectives, building on what we saw in section 2.1. One of them is the conditional, and that is used when you've got a statement form, if P then Q. That will look like P with that arrow, Q. We're going to talk about the truth tables, but let's first talk about the biconditional, which is an arrow with both ends pointed. And that's used for P if and only if Q, which can be written as P if with two F's, Q. Okay. And so that's just going to be P with that double arrow, Q. All right, so here are the truth tables. We've got on the left the conditional, and on the right the biconditional. Now let me say something about that conditional, is sometimes students have a hard time with that particular truth table. And I think the challenge is that some of the other connectives we've seen, like and or not, work pretty much the way that you would expect them to based on how we use those words in everyday language. This doesn't necessarily work how we would expect it to. And in particular, if you look at the last two rows, whenever P is false, if P then Q is true, which you may find a little bit hard to accept, but that's the way that this truth table works. And in fact, the only way that if P then Q is false is if P is true and Q is false. The biconditional is perhaps a little easier to accept as making sense, because when P and Q have the same truth value, the biconditional is true. So if they're both true, biconditional is true. If they're both false, the biconditional is true. And if they're mismatched, then the biconditional is false. Let's look at some related statements to this conditional statement. So one of the things that I want to talk about here is called the converse. And the converse of if P then Q is if Q then P. The inverse of if P then Q is if not Q then not P. If not P then not Q. One thing I want to note here about the converse and the inverse are that they are not logically equivalent to the original, but they are logically equivalent to each other. Now there's one more type, the contrapositive, which is logically equivalent to the original. And the contrapositive of if P then Q is if not Q then not P. Okay, it's helpful to keep that in mind. There will be times when we want to replace a conditional statement with its contrapositive. So it's helpful to bear in mind they are logically equivalent, so that makes it okay to do that substitution. Okay, let's look at a particular example. So we're going to look at if x is equal to 2, then y is greater than 3. That's a conditional statement. So we can talk about its converse. The converse would be if y is greater than 3, then x is equal to 2. The inverse would say if x is not equal to 2, then y is less than or equal to 3. And the contrapositive would say if y is less than or equal to 3, then x is not equal to 2. Okay. Let's talk about the negation of a conditional statement. So when we talk about a negation, we're just saying, we take that statement form and put a not in front of it. The negation of the conditional statement if P then Q is P and not Q. So very important to remember that the negation there is not a new conditional statement. And that is a very common mistake. On our first exam, I might say something like, here's a conditional statement, write the negation. And it's not uncommon for students to then write a new conditional statement, which is not what the negation of a conditional statement is. So using the notation we saw for logical equivalence, that's going to say that the negation of if P then Q is logically equivalent to P and not Q. So let's look at our specific example. If we start with if x equals 2, then y is greater than 3, the negation of that would say x is equal to 2 and y is less than or equal to 3. Okay, we're going to conclude with some equivalent ways, logically equivalent ways of saying if P then Q. Okay, so we have the notation with that connective, but we can also just write if P then Q. We could say if not Q then not P. That's the contrapositive we talked about. We could say P only if Q. Okay, that is equivalent to saying if P then Q. We won't see that a great deal, but from time to time you might see that only if come up. And these last two, P is a sufficient condition for Q, and Q is a necessary condition for P. There's some further discussion in the textbook about necessary and sufficient conditions, but for the purpose of this video, I just want you to be aware of how those relate back to if P then Q. That's it for this particular video. The next section, section 2.3, gets into valid and invalid arguments. Hope you found this helpful. I'll see you in the next video.